All right. I think it's time. Yep, it's a go time. I will begin. Heavenly Father, we thank you for this day. I thank you for these students, for the weather outside. And we thank you again, Lord, that you're an awesome God and that your love knows no bounds. Yeah, we thank you that you loved us while we were yet sinners, that you died for us, Lord. Guide our steps today. Help us to glorify you in what we do. In your name I pray, Lord Jesus. Amen. Okay, so today we are talking about parabolas. So, what is a parabola? So the standard form would be something like this. Y equals ax squared plus bx plus c, standard form. All right. And, you know what, for kicks, I'm just going to write the other popular forms. You could also write it in factored form. All right. And you could also write it in vertex form. And of course, each one of these has its advantages. All right. I think the standard form is just oftentimes kind of just the natural way the formula comes to us for whatever reason. The factored form lets you see X-intercepts without work. You can just see the X-intercepts from the formula. And the vertex form, it makes the vertex of the parabola manifest. Excuse me. So a picture generically could be something like this. So this point right here, I mean, this isn't totally generic. I'm assuming for my picture here that a is greater than 0, right? And if I have this, I can label some points on here for the generic like first of all, the y-intercept is at C, right? C is the y-intercept because when you plug in, so if I want to call this thing f of x also, okay guys? So C is f of 0 is equal to C. That's the y-intercept. And of course the R1 could be this, R2 could be that, all right? There's an axis of symmetry. So the parabola is symmetric about its excuse me, axis of symmetry, which goes straight down the middle, like so. And the vertex is on the axis of symmetry. The vertex I'm labeling h comma k. All right. So yeah, this is oftentimes what the parabola looks like, but not always, because you know, you can have parabolas where there are no x-intercepts, right? So let's study that. Example 1. Suppose we're looking at y equals, I don't know, x minus 2, excuse me, x squared minus 4x. I don't know, minus 1. Wait, minus 1? No, plus 18 there, no, it's too much, I'm sorry, I'll make up my mind here eventually. 9, I'll put a 9 there. 5 would have been good, but I did 5 earlier today, so I'm bored with that one. Okay, so 9. So in order to understand the graph, the smart thing to do here is complete the square. So if we complete the square, we have x minus 2 quantity squared right? Then I subtract 4, I add 9. So what I get is x minus 2 quantity squared plus 5. All right? Now that shows me where the vertex is. See, because I can compare, I can pattern match the generic vertex form equation with what I have right here, right? So compare. Match the pattern. What do you see? H equals to what? Yeah, so H comma K equals to 2 comma 5. The vertex is at 2 comma 5. Yep.
Would the negative further still apply or no?
The negative, well, notice that the negative needs to be there.
Oh, okay.
Yeah, so the negative matters. Just like here, the minus matters. See, the factored form has X-intercepts, right? R1 comma 0, R2 comma 0, X-intercepts, yeah? And that minus is important. Has to be there. If it's not there, you got to make it appear so that you're not wrong. Now, okay, so we can graph. We can graph. See, because we know where the vertex is, yeah? And poor planning on my part. Let's see here. All right. Well, I'm not going to make it have the same scale, okay? 1, 2, 3, 4. My scale on the x and the y is not the same, yeah? All right, so what points do we know on the graph? Well, we know the vertex, right? It's at 2 comma 5, so that's about here, right? What other point do I know on the graph? Without really working more. How about this? This 9. That tells me the y-intercept is 9, right? I've got 2 points on the graph, and one of those points is the vertex. That's enough to graph the parabola bid by the symmetry. Like the symmetry says that it reflects across the, oh man. So it's got to be something like this. So this point mirrors over to this point over here. Like this is 2 units over. So this point up here is 0, 9. There's a mirror point over here of 4, 9, like that. Okay. So there you go. That's the graph of y equals x squared minus 4x plus 9. Yep.
What would the formula need to look like for the parabolas be on the other side of the y-axis?
In what sense?
Like instead of having the vertex up in the positive.
Do you mean it still opens up?
Yeah, it still opens up.
Okay, great. Good question. Example 2. Well, let me put it over here. Suppose we had y equals to x squared, plus 16x, all right? And then minus 1, there. Fine. Ugly, but we can do it. All right, so complete the square here. We get x plus 8 quantity squared. Yeah, minus 64 minus 1. So from this, I can see vertex at minus 8 comma, minus 65, right? But I can do more. I can put this into factored form. See, because this is x plus 8 plus the square root of 65 times x plus 8 minus the square root of 65.
But why do you need that if you have to buy to shift it? -1.
We don't, I mean, what do we need? I don't know. I mean, need not,
What do you want it?
because now I know where the x-intercepts are. See, so this tells me x-intercept minus 8 minus the square root of 65 is R1, let's say, and R2 is minus 8 plus the square root of 65.
You just have to do calculations and
Right, and we can approximate, square root of 65 is awful close to the square root of 64, right? So square root of 65 is like 8.1-ish, you know? So that makes R1 approximately minus 16.1. That makes R2 approximately, yeah, 0.1, right? Just a little bit positive, not much. And so I know where the x-intercepts are, yeah? I know where the y-intercept is, I know where the vertex is, I can graph this thing. And so here it is. I better make my scale kind of big, right? So 60, I need a minus 8. I'm going to make this minus 30, minus 60. It's okay, we'll deal. 30. All right, and then for the other scale, I'll do like this is make this, let's see here. Oh, sure, I can make it 10 and 20 if you'd like. Why not? I can do that. All right, fine. I think I think my graph is big enough that I can tell the story I need to here. So, great. The vertex is at minus 8, right? So roughly speaking, that's like, I'm going to draw the axis of symmetry to keep me honest, or try anyway. Try to keep me honest. The vertex is about right here. Yeah? And you've got x-intercepts at close to 0, right? Actually, it's a little bit positive, right? Sorry, a little bit positive. So that side is 0. And also at, wait a minute. Yeah. Thank you. So my bad. I was supposed to put the, what did I just get done saying? The vertex is where? Minus 8.
Mm-hmm.
Dummy. Me, not you. Okay, so the vertex is over here. You've got one x-intercept over here. You got the other x-intercept like over at minus 16, right? And so, and there's also a y-intercept where? Well, the y-intercept is at like minus 1. So that's not terribly helpful. It's about right there. Anyway, so it looks something like this. Let me get rid of this spurious mistake axis over here. There we go. But just to be precise, we can label the x-intercepts, right? X-intercepts minus 8 minus the square root of 65 on this side. And this one is, you know, minus 8 plus the square root of 65 is my x-intercept over there. And my vertex down here is minus 8 minus 65. So there's an answer to your question. You asked me for one that, you know, and so what's the big difference? When we complete the square, we get plus, right? Complete the square, we get minus. This corresponds, this being a prime polynomial, which means actually that its factored form involves complex numbers, which is to say that there really aren't x-intercepts, right? No x-intercept. And on the other hand, over here, there are x-intercepts, namely minus 8 plus or minus the square root of 65. So that means that it crosses the x-axis, right? Yeah.
I'm going to ask a question that may be a little down here. So every time you have a positive factored form, it's always prime?
Every time we have a positive factored form, it's always prime. It depends on what you mean by positive, I suppose.
That one up there is positive also?
This one? The example 1?
Yeah.
So that's, yeah. Anytime it's positive, that means it's prime.
It
Now,
will always be prime.
it will always be prime?
Yeah.
Um,
Because instead of a 5, you have 4 or 3 or 2.
Oh, yes. So this one here, by the way, the factored form looks like this, right? So 5, let's just take a second and appreciate what that would look like. 5 I can rewrite as minus parentheses I times the square root of 5 squared. See, because I squared is minus 1. I'll come back to your question in just a second. Minus I squared is minus 1, right? So I can rewrite 5 as I times the square root of 5 squared. Square this, you get minus 1 times the square root of 5 squared, which is 5. You get minus 5. Minus and minus 5 is plus 5. We're back there, right? This is difference of squares, so I can factor it. X minus 2 plus I root 5. X minus 2 minus I root 5. So you see the roots here. R1 is 2 minus I root 5. And R2 is 2 plus I root 5. These do not correspond geometrically to x-intercepts, right? They're complex numbers. The algebra still works. You can still put any quadratic into its factored form, but beware, if it's a prime polynomial, the factors are complex, right? So it doesn't have the geometric use anymore.
And it will always be prime if it's a plus.
It'll always be prime if
Greater
it's
than 0.
a plus. Yeah, I think that's right. Unless there's like a minus in front of the square. What was your question?
On the graph, when you do the point -8 minus square root of 65,
Mm-hmm.
when you're actually drawing it, would it be to the right of -10?
Yes, to the right of negative 10.
Okay.
Because minus 8, you know,
Minus 8 is the x.
we got minus 10, we got minus 5 over here, like minus 8 is there on the number line.
Yeah.
So,
Just how, like the point -8, no, the one above it. Is that one supposed to be to the right of -10 too, because it's -8 minus square root?
yeah, well, it should be to the left of minus 10 because it's minus 16, so it's like over there.
Oh, okay.
Whereas that one's about 0.1, so I think it's okay.
Okay.
But, okay, so here, check this one out. Y equals to, I don't know, minus 2x squared, minus 4x, plus 10. All right, fine.
You can factor out the 2.
We can factor out the 2. Hey, but got to be careful, that's a plus, right? Because minus, okay, and then over here, I get minus 5, yeah? So complete the square. And minus 1, minus 5, right? So I get minus 2. Did you pan over? Because I panned back and then, yeah, it's all good. All right, so this is, I mean, it's a lovely formula, but it doesn't quite answer any of the questions we're interested in. It's not vertex form. Notice what vertex form is. Vertex form is A times x minus h quantity squared plus k, right? So the A only multiplies the x minus h, right? It does not multiply both terms. So we have to just work it out a bit. This is minus 2 times x plus 1 squared plus 12. So you said, is it always prime if it's positive? Depends on what you mean. See, because here it's positive, but it's not prime. But that's because I've got a minus in the front.
So that
Yeah.
depends on the first
Right.
first coefficient.
Yeah, so I'll keep working on this one, but the vertex is where? Minus 112, right. And where are the x-intercepts here? One and 6, I don't think so. Let me pick on this one up here. See, this is minus 2 times x plus 1 plus the square root of 6 times x plus 1 minus the square root of 6. Because we look at 6 as the square root of 6 squared, right? We look at 6 as the square root of 6 squared, yeah? And so it's the difference of squares. I've got a plus b times a minus b. And so from that, I can see the x-intercepts are where? This gives me r1 minus 1 minus the square root of 6, and r2 minus 1 plus the square root of 6. So the x-intercepts are a little bit ugly here. This one opens down, yeah? Let's see here, so if I can do it. What's the square root of 6? 2.5-ish? Is it? I don't know, I left my calculator home today, sorry guys. This is approximately minus 3.5. This is approximately 1.5, I think. So here's minus 1, here's 1, 2.45. Aha, I was right, kind of. I mean, close anyway. Minus 2, up to the limits of my artistry anyway. So where is the vertex? The vertex is at minus 112, right? That's the axis of symmetry. Let me put a dotted line in there just to keep myself, hopefully keep myself a little bit honest here with the graph. Right, where's the vertex? Minus 1 comma 12. So that guy is up here-ish. All right. Apparently this is 12. And, great. And then what? Where's its x-intercepts? Well, the y-intercept is what? 10? Yeah? See? Right here. So it's got a y-intercept of, if this is 6, 10 is kind of here. Right? That's a point. And it has an x-intercept of 1.5-ish. And it has another x-intercept of minus 3.5, which I haven't quite got to yet. If I might have done an arithmetic mistake, yeah?
I have a question.
Sure.
Would you be able to push the y-intercept 2 units to the left, considering it's just a minus 1 to the right? You push 1 to the left?
What?
Symmetry?
Oh, you want to get a mirror point over there? Oh, yeah. Sure. If this is 10, then yeah, you can get. See, my scale isn't quite. I'm spacing these out more than I'm supposed to. I need some graph paper. What can I tell you? My points over here were getting my tick marks were getting too separated. It's making me look bad. But you're right, Francisco. Like we can mirror the point over there to this one, right? Mm-hmm. Roughly speaking, and minus.
You need the x-intercepts if you do that.
Well, I don't know. I mean.
You know how much it opens up?
I think the more you know, the better it looks. But so there we go. But I mean, generically speaking, it's very likely I have a test question where I say, or quiz question where I say, find vertex, find x-intercepts, if there are any. There's always a vertex, right? Every parabola has a vertex. Mm-hmm. Not every parabola has x-intercepts, right?
My question
Some do, some don't.
Do you actually need the x-intercepts if you can mirror the points?
Do you actually need? Well, I mean. Yes and no. I mean, the question is like, how do you actually get a sense of the scale, you know? If you have some points which are further away in the y, it helps you kind of set the shape of the parabola better, I think is one of the main answers to that question. But to answer your other question, is it, if it's plus, is it prime? Yes and no. I mean, if the coefficient over here is negative, that plus doesn't help you, right? Because the question is what happens inside the parentheses as you're completing the square. If as you're completing the square, in the space where the square is being completed, right, in that part of the algebra, if that presents a negative, then yeah, it's not prime.
Now see, that presents another question. What if the first coefficient is positive?
Well, that's what we did over here.
No, oh, right, that's a
Mm-hmm.
1.
So the question that the first section today asked me at this point was, I don't want to complete the square. I mean, they didn't quite say it that way, but in your heart, half of you are like, I don't want to complete the square. I already got burnt on it. In test 1 and quiz 1, right? I mean, statistically speaking, half of you cannot complete the square at this point. All right? Actually, I'm not sure. I forget. I just grade all the sections. Maybe all of you guys know. I can't remember. But it is something you need to learn. And but just take a step back here. What if you can't complete the square because you've just got, I mean, you get, like, let's suppose you get a flu later in the semester, and part of that flu, the symptoms of it is inability to complete the square, right? It's a very specific, it's an engineered Chinese virus specifically, Russian virus that has been specifically engineered to stop people from completing the square. I mean, why not, right? Yeah. Right, and we don't have any vaccines yet, which are like heart attackingly good to fix it. So let's see here. So the question is, where's the vertex, right? Did I say something? Did I?
No, you're okay.
Did I stutter? Let's see here. Y equals to ax squared plus bx plus c. All right, where is the vertex? I mean, yes, I know we can complete the square, right? But what is the formula for the vertex? You guys like formulas, right? Let's find it. So what we're going to do is we're going to do the same thing I've done in all the examples so far today. Did you already pan over? Okay, thanks. We're going to complete the square. First of all, we factor the a out. Then we're going to complete the square. When we add b over 2a squared, we have to subtract b squared over 4a squared. You still got your c over a over there, like so. And now I'm going to clean things up a bit. See, this time I'm not after factoring. I'm after the vertex form. So I do a times x plus b over 2a squared. All right. I'm going to multiply the a through these last two terms. I'm going to keep the c first because it makes it pretty. And then minus b over 4a. B squared rather over 4a. Okay, great. This is the vertex form. But I've written it with a, b, and c, right? So now you can compare this to the vertex form. Namely, a times x minus h squared, right? Plus k. And if we compare these, what are the formulas? H equals to what? H equals to? Minus b over 2a. Mind the minus, yeah? And k, c minus b squared over 4a. So there you go. Those are stone cold formulas for the vertex in terms of the coefficients of the parabola. In terms of the coefficient of the standard form. Now, why didn't I lead with that? Why haven't we just been plugging numbers into that? Because it is far wiser for you to work on completing the square, which is part of the course, and you need to figure out how to do it. It's also faster just to complete the square than it is to use these formulas. But we can try them out. Like, does it work? Like, are these formulas legit? For example 7, was it? 3, I can't read. So example 3 continued, does it work? Let's see here. So we had what? Y equal to minus 2x squared minus 4x plus 10, yeah? So what would my formula be? So here A is equal to what? Minus 2, B is equal to minus 4, C is equal to 10, right? So if we don't want to complete the square, we just want to plug and chug the formula. Here we go. H equals to minus a minus 4 divided by 2 times a minus a 2. And that gives us what? 4 over minus 4, also known as minus 1, right? So we got 4 over minus 4 is minus 1. Is that what H was? Okay, good. Okay, if it didn't work out to minus 1, I'd be in trouble. C is 10, you know, but math is like that sometime, right? Sometimes math cares about authentic voices and about, you know, listening to various people's stories and histories. Oh, it doesn't, does it? It just cares about truth. Let's see here. 4 squared over 4 minus 2. Sorry, math is not postmodern. There's just the truth, not your truth. 10, we got 16 over minus 8, so that's minus 2. 10, so we got ourselves what? 10 minus a minus 2, also known as 10 plus 2, also known as 12. It was 12, right? Oh, okay, good, good. I need glasses. So, I mean, is this better or is that better? I don't know.
Wait, so we can do this way?
Yeah. I wouldn't do it this way because I forget these formulas. You guys got a formula sheet. Why did I let you have a formula sheet? Dang it. It's too late. Next semester, I'm going to remember no formula sheets. And then you guys can find my students next semester and be like, Dr. Cook let us have a formula sheet last semester. And they'll be like, ah, curse you, you know, something like that. But generic curse. But none of you should be my students next semester, though, to be clear, right?
What if I just like...
Okay. No recycling. What's that?
What if I really miss you?
You just really miss me? Well, then, like, come take another course, like, I don't know, like Calculus 2.
Oh boy.
Oh, yeah.
Just skip Calculus 1 and pre-calculus. Just come join us in Calculus 2. It's just algebra.
I can't even do this.
It's all algebra. Like, most of the math, like, going up, it's just algebra. It's just one step at a time, you know? Let's see if we can find another example. Oh, before I forget, I should point out some things. There are some really neat patterns to see here, right? What happens over, are we still, oh, sorry. Making you work today. Where are the X-intercepts? That's also a question we should ask, right? I'm sure this has been more emphasized in your previous coursework, right? This is where the quadratic is equal to 0, right? So we're looking for ax squared plus bx plus c equals to 0. What is the solution to that? You know it, you love it. Many of you think it factors. It's not factoring. Plus or minus the square root. I saw lots of this. I asked you guys to factor on the test and you spit this thing back at me like, it's like you're trying to offend me or something. I don't know. Mission accomplished. Don't tell my son. He's always looking for ways to offend me. He's gotten better at it lately. What's that?
Does he look at your videos?
No, they don't look at my videos. Our secrets are safe here. So
That's why you talked about the cookies in the fridge last night.
that's right. Yes, they still found them though, in like 3 seconds.
You didn't say it on video though.
Yeah.
Bring him to school and wait for him. That's a good idea.
Yes, I do need to. My mom made me some chocolate chip cookies, and I do need to bring them to school, where they will be safe. Keep them secret. keep it safe.
Then you have to
So-
share it with your students.
This will find the x-intercepts, right? This is equal to, this gives you the R1 and the R2, right? Let's, for the sake of discussion, let's say R1 comes with a plus and R2 comes with a minus, all right? That gives you the roots. What happens if you add R1 and R2? Do you guys see it? What's R1 plus R2? I don't want to actually write it out, but think about it. When you add this formula to itself with the plus versus the minus, what happens? The plus term and the minus term,
Cancel out.
they cancel out. You're just left with minus b over 2a plus minus b over 2a, also known as minus b over a, because a half plus a half is 1, right? And then from this, notice that we have R1 plus R2 divided by 2 is equal to minus b over 2a. Now the reason I divided by 2 is because this has significance. You know, give me 15 and 30. What's the average of them? What do you do? 15 plus 30, you divide by 2, right? So 45 over 2, 22.5 is the average of 15 and 30, right? Let's pick something less weird. 3 and 7, what's the average? 3 plus 7 is 10. 10 divided by 2 is 5. 5 is the average of 3 and 7, right? This is the average of the roots, right? It's halfway between the roots. What's this? It's minus b over 2a. What is this, though? It's h, yeah. So this is another thing we should know about. The average of the roots has to be where the vertex is. The vertex always has to be halfway in between the roots. The cool thing about the boxed formula is it's still true when R1 and R2 are complex.
Is that like a formula?
Yeah, it's a formula, like that. I sometimes add this to it because it's like it rises to the level of what I would call a theorem. Do you know what a theorem means?
No.
What theorem, the term theorem means basically? Like the
law?
it essentially means, hey, look at this, it's interesting. It's just like a fancy way of saying that, that's all it means. Hey, this is of note, it's noteworthy. That's what a theorem is. Anyway, yeah. And if you look at the examples we've done today, this has been the case, right? Every time, the average of the x-intercepts, halfway between them, is where the vertex is, right? In the one that had complex, let me do another complex one right quick here. Where am I? What example am I on? 4, thank you. So here's one. Oh, I don't know. Y equals to one of my favorite one, x squared plus 4x plus 5. You complete the square on this thing. You got x plus 2 squared minus 4 plus 5. So you got x plus 2 squared plus 1. So we've got a vertex at minus 2 vertex, right? And so the vertex is at minus 2, 1, and its x-intercept is, it used to be y-intercept. It's like up here, so roughly speaking, this thing looks something like this. All right. So one of the things I would point out to you that's kind of funny, what are the roots to this one? If you study x plus 2 squared, right? Minus 2, right? Sorry. X plus 2 squared equals to minus 1, right? You get x plus 2 equals to plus or minus the square root of minus 1. X equals to minus 2 plus or minus I, right? Those are the roots to the quadratic equation here. What's the average of the roots? See, in the complex case, in the case that you have complex roots, the real part of your answer is where the vertex is. That's its meaning. The real part of the complex root is where the vertex is. See, minus 2 is the real part of both of your roots. Okay. So if you want to know the geometric significance of a complex root, that's it. The real part is where the vertex is, in the x sense. I've only told that to you guys. The other sections didn't get to learn this. So, why? Because it's earlier in the day. I'm not awake yet. Pretty much. I'd love to give a more, satisfying answer. It's some reflection on them being worse students than you guys or something like that. Something I could tear them down to build you guys up. I mean, I could do that if you'd like. But it wouldn't be from the heart, I like all my classes. I'm just joking. All right, let's see here. So, yes, here's an example we should chew on for a second before I forget. Example 5. What if you come up against y equals minus 2x squared minus 4x minus 2? What are we going to do with this guy? I mean, maybe make a 4, make that a plus, just to get us a little bit more experience with factoring here. So factor out the minus 2. Okay, so then we got x squared minus 2x, yeah, plus 1. Now what? Minus 2x what? X minus 1 squared? Yeah. So it factors. And so this is an interesting one because, if you look at this, you can add 0 here, right? And you can see h comma k is what? I have to add 0, just so you can see. 1, 0, right? But what is 1, 0 also? It's the vertex, but it's also what? It's also the root, right? Yeah, it's also the x-intercept, right? Here the x-intercept and the vertex are one and the same. This is a special case. This is the case where the discriminant is 0, right? The b squared minus 4ac is 0. So x-intercept. And not only is the x-intercept the vertex, there's just one x-intercept, right? There's not an R1 and R2, there's just R1 equals to R2, right? They become one and the same. And so, we can graph this thing. What's the y-intercept? Right here, right? Minus 2, so. And so there you have it. This thing looks something like that. Does that make sense? I hope. I like to say in this case that the parabola bounces off the x-axis, all right? And I'm going to use that language again Monday when we're talking about graphing parabolas. All right, I mean not parabolas, but more general polynomials, okay? I like this language. If the graph looks like this, if it just kind of touches the x-axis and then goes away from it, we say it bounces on such a point, yeah? Example 6. Suppose you got y equals to f of x equals to 3 times x minus 2 times x plus, I don't know, 7. Find the vertex. Can you guys do it? I can think of 3 ways. 3 genuinely different ways. I'm going to do it the way I think is easiest for you, okay? So I think the easiest way here is to look at it and go, aha, I know what the roots are. What are the roots? 2 and minus 7, right? R1 equals to 2, R2 equals to minus 7. So what's the average of the roots? I've got minus 5 over 2, right? So the average of the roots is minus 5/2. That's my h, right? That's the h. Now, I need to find the vertex, right? That's half of the vertex. What's the other half? The k. How do I find k? So here's the idea. K has to be equal to f of h. Think about this. The vertex is a point on the graph, so it satisfies the equation y equals f of x. So when you plug in h, you should get back out k, right? That's the way to think about this one here. So we know h is minus 5/2. So I need to calculate f of minus 5/2, which is, kind of a drag, but we can do it. 3 times minus 5/2 minus 2 minus 5/2 plus 7, right? Whatever that is. Let's see here, 3 times minus 9 over 2, 14, is that 9 over 2? Which is what? What's 81 times 3? Minus 243 over 4. Is that right? 81 times 3, 243? That feels right. Okay, so vertex is apparently minus 5/2, comma, minus 243 over 4. Can you guys tell me what's the other way that maybe some of you were thinking about doing this problem? What's another path you could go down here? Nobody? How about this? I say, instead, I'm going to look at f of x equal to, y equal f of x, which is, in this case, 3 times, multiply it out, yeah? X squared. I got a minus 2x, a plus 7x, so I get a plus 5x as I FOIL it out, minus 14. So that gives me 3x squared plus 15x minus 42. So recognize a equals 3, b equals 15, c equals minus 42, h equals minus b over 2a, k equals to c minus b squared over 4a. Do the math. You got yourself a minus 15 over 2 times 3, right? Which is minus 5/2. And the c is minus 42, b squared, 15 squared, yeah? Divided by 4 times 3. And so however that works out, you got minus 42. 15 is what? 3 times 5. So you've got, 15 times, so you got, let me just write out here, 3 times 5 times 3 times 5 over 4 times 3. So I can cancel the 3's, and I'm left with, like, minus 15 times 5, 75 over 4, I guess. How many 4's are 42? I think it's 168. 168 plus 75 is 243. So, yep. Which way is better? I think the answer is yes, right? I mean, either way is okay. But my point to you is, if you understand the formulas, right, that we've talked about today, there's this whole interconnected web of ideas here. All of these ideas feed on each other, and they all flow into making a better graph for the parabola. So, have a good weekend, you guys. If you can hit the, well, the mean girls are really nice today. You guys don't want to be called the mean girls? No? I think it's kind of like a badge of honor. That means that you're the cool